In this episode of Hot Hardware's 2.5 Geeks, we're going to be talking all things Meteor Lake, Intel Meteor Lake, in fact, with some very cool dudes from Intel. Next. Welcome back, ladies and gentlemen, brothers and sisters. Dave Altavilla for Hot Hardware here, hothardware.com. As always, welcome to our 2.5 Geeks live stream. Fridays at 1 o'clock now, which is kind of a little bit more relaxed, get the weekend on our mind kind of time slot, which we like. But as always with me, the illustrious and effervescent Marco Chiplets. How you doing today, brother?
I'm doing okay. I need to apologize to everybody in advance. I'm a little under the weather, so if you hear any strange sounds coming from my end, I apologize if I didn't mute in time, but I'll do my best to stay coherent and sound okay throughout all of this.
What folks probably don't know is that we've come to tolerate strange sounds coming from Marco on occasion, so that's okay.
It's a signature of my personality. It's just how things go.
And also with us, the man behind the curtain, Chris Getting with the knobs and dials. He'll be here maybe in an unembodied voice on occasion, or he might pop on. We don't know, right, Chris?
Yep. How's it going?
Yeah, how's it going? It's going well because we have two very special guests from Intel. We have Dan Rogers and Robert Hallock from Intel Corporation. Gentlemen, welcome to the live stream, and thank you so much for your time and for joining us this morning.
Yeah, good to be here.
Great to be here.
Yeah, and let's start with a quick little introduction for folks that don't know you guys. You are all things Intel client, and by that I mean laptops and desktops and all that fun stuff. Intel CCG, as the business unit is known internally. Could you help with your name, rank, and serial number, your titles, and your purview? Why don't we start with Robert? Because Robert's he's in a different badge than we remember him from.
Yeah, I've had a change of paint colors. No, I lead technical marketing for client CPUs, but of course supported by a ton of amazing technical marketing staff at Intel. The scale of the organization is enormous compared to what I'm accustomed to. It's been a lot of fun.
There you go. Robert, previously with AMD, as you folks may know, now has arrived at Intel to bestow his talents upon all things CPU. Good to have you with us, Robert. Thank you very much.
Thanks for having me. Yeah.
Yeah, and Daniel, you're almost a regular on the show now too. We've had you one or two times. Good to see you again. Tell the folks what you do at Intel. Be great to.
Yeah, great to be back. Feels like home. So I'm Dan Rogers. I was previously the Alder Lake and Raptor Lake product marketing manager, which was products like we're super proud of. But happy to kind of turn the page today and talk about our latest product, Meteor Lake. I'm in a new capacity, so now I manage our client performance marketing lab here at Intel.
Client performance marketing lab. I didn't realize that. When did you shift that gear? Is that
sort of graduated after Alder Raptor and was excited to take on a more performance centric role, technical marketing type of function. So we're really happy to have Robert on board and talk about this new chip.
Excellent. Well, that's fun stuff because that's the world we live in: performance analysis and understanding all the nuances of system performance, whether it be laptops or desktops, gaming or otherwise. And yeah, great stuff. All right. Well, we won't banter much without further ado. But Marco, you want to set some ground rules for the folks in the chat and whatnot, and we'll go from there.
Yeah, so we have some of our own questions. Obviously, we would love questions from the chat. Just know there's no way we're going to get answers on future product or anything like that. So if you ask a question that perhaps there's no chance of getting an answer for, we may skip it. But please keep it cordial. We want to hear from everybody. If you're on another platform like LinkedIn or Twitter, we won't see that live chat. So it would be best if you came over to YouTube or Facebook or Twitch for that. But yeah, there's no ground rules. Keep it, keep things civil, and we will try to get to as many questions as we can. But I think we'll kick it off with something high level. We have an in-depth architecture piece on HotHardware. Chris was out in Malaysia, got the deep dive, and did a phenomenal job on our Meteor Lake coverage, I think. So definitely stop by the site and check that out. There's lots of information about literally every piece of Meteor Lake. But why don't one of you guys from Intel, let's give the high level on what separates Meteor Lake from previous gen Intel architectures.
That would be great.
Yeah. Well, let's see. Let's start with how it's built. That's a big change. I think people are accustomed to seeing Intel CPUs use a monolithic die for most of the market segments, or a couple tiles, 1 to 2 tiles. Meteor Lake has many tiles: GPU, CPU cores, I/O, and the SoC tile, like the chipset tile, right? And then I guess there's one below that. That's the interposer, the base tile, right? So we're looking at 5 different tiles, and that gives Intel a ton of flexibility in customizing the package for different markets, scaling performance up and down. Process node on all the tiles is different. The star of the show is the Intel 4 process on the CPU cores, considerably more dense for logic, much better for power efficiency, and like more or less we cut power in about half on this SoC gen on gen. So like huge advancements in performance per watt. Graphics is about twice as fast as last year. You've got an AI accelerator now. It's a total reimagining of the CPU versus last year. It's not iterative as CPUs tend to be.
Very cool. Dan, anything to add there?
Yeah, I think that's a great summary to start. And Dave and Marco, I think I just highlight too is like as impressive and excited as we are about Meteor Lake, the immediate product for later this year and into next year. At the architecture level, this is really sort of an all new platform for us, right? You could think about it as like a new way that we're going to do client chip design here at Intel. And we think that our Foveros technology and approach to chiplets in the way that we're bringing this to market is really distinguished and advantageous. And we're like super excited about how we like kind of start this revolution with Meteor Lake and then carry that forward over the course of the next several years. So yeah, it's really a major inflection point in the way we're approaching the PC.
Very cool. And actually, you mentioned Foveros. Let's talk about that real quick, because that's an interesting aspect of the chip design that I think is just really cool. Your first effort with Foveros was with something called Lakefield, if I'm not mistaken.
That's right.
That chip kind of, I think, the execution on that wasn't exactly what, or maybe not the execution, but the outcome of that chip wasn't exactly perhaps what you had hoped for. It didn't really get a lot of traction, to be honest. This is your, another usage of Foveros and a higher end architecture, obviously, than Lakefield was. What have you learned along the way? And is this Foveros 2.0 or 3.0 or whatever? Maybe talk a little bit about that. What makes Foveros different this time?
Dan, why don't you take that one? You have a lot of history with Foveros.
Yeah, sure. Dave, I think it's an interesting kind of look back, right, to talk about Lakefield, because in a lot of ways that chip has been actually quite important as we move forward in the roadmap. So it set the stage for some of the software infrastructure that we proved out then in Alder Lake and Raptor Lake. And now as you're referencing, right, it was our first client Foveros chiplet, and now we see that here in Meteor Lake. It is a newer version of Foveros, so it's the latest flavor of the technology. And we're using it in a different way this time. So as Robert kind of mentioned, it's sort of like 4 + 1. So there's 4 chiplets on the top, and then a passive base die to connect everything. And the magic of Foveros is that you get all the benefits of a disaggregated architecture with a lot of the benefits of a monolithic architecture. So you still get really great power, really great wire density, really high bandwidth. So for our architecture team, they can almost design a chip as if it is monolithic, but then match all the right IPs to chiplets to process flavors to get that benefit of disaggregation. So we really think it's the best of both worlds, and it's why it's now the backbone of our entire client roadmap going forward.
Yeah, yeah, good stuff. It's good to, you could, certainly could say that Lakefield was that test vehicle for you, or proof of concept vehicle almost for you, and now the refinements are showing through quite clearly. Cool stuff. I have a follow up to that, but Chris, I noticed you popped on screen. Did you have something you wanted to chime in with? You're muted, buddy.
No,
I just got a question for
$5.
a little more detail on that mysterious fifth tile. So that's not carrying any transistors on it. It's just interconnect between the chips. Is there an idea of what kind of process it would be? I think they said internally you call it process 1227 during the Q&A while I was out in Malaysia. But what's the actual scale of that compared to what you're running with Intel 4 or TSMC 5, 6, what have you?
Yeah, it's we have an internal process code name for it, but it's a passive base tile in the Meteor Lake architecture, and it's an important part, but it's really the star of the show is of course it is in the logic layer, so in the four chiplets, which we'll unpack more in the rest of the show, but it serves this really important role in it, like the way we describe Foveros as a holistic 3D die stacking and patching technology, that it allows this kind of like monolithic type approach, but with the benefits of disaggregation. So you can think of it really as, Chris, more of an enabler than really the star of the show from a process technology itself. And then in the future, of course, we're looking at ways to take further advantage of that going forward.
Very cool.
Thank you.
Meteor Lake and the disaggregated nature of it. It has a very different approach, as you noted, versus previous gen Intel architectures. There's all of these individual tiles on board, and what did Intel do to mitigate? To me, I would think with that disaggregation comes latency. What did Intel do to help mitigate latency to system resources, whether it be memory or even on chip cache, because it is so disaggregated?
Well, you've actually got the right diagram there. Thinking about the floor planning of the chip is essential, where you're going to cut the different tiles up. Comparatively to monolithic, where would you cut that chip up into tiles? And the great thing about Foveros and having that passive interposer on the bottom is the wire length is extremely short. We call it wire latency inside the industry, but we're talking nanoseconds here, and because everything is essentially next door and monolithic like in nature, it's not really something that's gonna affect the outcome, right? It's so tightly packed and so tightly integrated. Dan's right. We think of it as a monolithic design in terms of implementation, even though things are disparate, disaggregated.
Very cool. Yeah.
Yeah. So in my write-up, I kind of hinted that you have a new power management approach separating things out, but I didn't get the chance to go into a ton of detail with that. If you could provide a little more color on that and how that maybe impacts latency, because you're shutting off tiles, turning them on. What kind of latency might you experience with that, or if any at all?
Dan, go ahead on that one.
Yeah. So certainly there's some notion of latency, just in the physical space from compute to memory. So there needs to be some thought process there. But as we kind of touched on earlier, Foveros really is almost magical in that that penalty ends up being kind of small, relative to the benefits that we see across the other vectors. Chris, on the PD point, right, and how we're managing power management across the tiles and making sure that we're waking up in time. This is where we're relying quite a bit on our thread director technology, so to make sure that we have all of our firmware, our operating system, and the whole stack working effectively, so that we can, as an Alder Lake, have the right thread placement at the right time. Now we're managing that in a new third tier of hybrid, with E-cores actually in the SoC tile, deliberately architected for power. So we're using that same infrastructure. And then, between the firmware and the operating system, we have to make sure that we give that responsiveness and upgrade up to the P cores when it's needed, or then get the power benefits when we can shut things down and run more efficiently.
Cool, Marco. I think there's a question in the chat. You wanna tee that up? Maybe that's related to the IO tile.
Yeah, so this is probably going to be a real softball, but I'm going to turn it into a minefield for you guys afterwards.
All right, let's go.
So we have KW asking, why does the IO tile not have Thunderbolt 5 since Intel has announced Thunderbolt 5 at this point?
Oh, I think that's the standard. These technologies are developed in parallel, and Thunderbolt 5 is coming online the same time that Meteor Lake is coming online. So the intersect point isn't there in that product, and that's just the roadmap. That's how it goes sometime. But that could be true of PCI Express or USB standards. We see this all the time in the industry.
And remember that we need something in the device, right, to connect to. So it sort of makes sense. You start with your discrete roadmap, and then you build out your ecosystem, and then from there we do the integration steps. So, we're excited to integrate in the future, but more to come on that.
So, is there an opportunity for device manufacturer to have a discrete Thunderbolt 5 solution in a Meteor Lake system?
We're not expecting that combination, Chris, at least not immediately here in the short term. So, we're expecting most Meteor Lake devices to use the Thunderbolt 4 solution that we have integrated in the product.
Yep.
Got it.
So because Meteor Lake is disaggregated and you guys have this technology where you can use tiles. Now, I know we can't speak to a specific product or roadmap, what have you, but theoretically, does this enable Intel now down the line to more quickly iterate on a product? And if there is something like Thunderbolt you want to integrate, perhaps only a single tile changes, or does this platform sort of open up a semi-custom business for you guys as well?
I think you kind of nailed it. How this solution is the most flexible of its kind. The tile that contains USB and Thunderbolt and PCI Express is itself its own tile. So yes, theoretically that could be swapped out for something else. You'd need to think about the pin out long term of adding more bandwidth. We know that bandwidth costs pins, but hypothetically, theoretically, yes, that's something you could do. And I think one of the questions that is unasked for now, but on people's minds, is how is that different from AMD's chiplet technology? And we know that their I/O die packs everything in: memory controllers, USB connectivity, PCI Express connectivity. So that's a wholesale change to the CPU when you want to swap that I/O tile out for them. Versus on the Intel side, it's even finer grained. It's more, it's sliced in more directions, which provides more flexibility, even within that product or long term on a roadmap point of view.
Yep. And there's kind of two ways to think about that flexibility that Robert just described, right? There's sort of like the intra-Meteor Lake flexibility, and that we can target IPs and process technologies very deliberately. And like we could have, like conceptually, we could scale up the number of chiplets or down, right? Depending upon each product's needs. But then like from a roadmap point of view, we can then, Dave, and I think this is like kind of where we're going with the question, right? Like you could think of ways that we can update and move forward like asymmetrically across the portfolio of chiplets. So that's another benefit that we have, like, so one within the product and then one like across the roadmap as we look forward. So it's why Meteor Lake is really such a notable architecture. And, we're happy to kind of unpack the details here for the first time. It marks, as impressive it is as a product, it marks a major revolution in the way that we're building the PC architecture now.
Very cool. I just want to make an observation, and I don't want to enlarge Robert's ego so much that his head blows outside the frame. But you've been with Intel for what, 6 weeks, maybe, I think?
Yeah,
and
about right.
And your technical depth on this brand new architecture is impressive, my friend.
Oh, thanks. Appreciate that. It's been cram season here. I have a lot to catch up on. Well, I came in. Yeah, I know. I came in like 2 weeks before the Malaysia event, and Dan hands me a stack of PowerPoints. He's like, "Here, read this. This is your homework." I'm like, "Oh, okay. Here we go." It's been fun. It's been fun. It's a great part.
Oh,
so
cool.
I want to sort of stick closer to Meteor Lake, but as you guys are talking, stuff is popping in my head that I'd love to get some color on. So I recently moderated a panel with an EDA tools company, and Intel was actually a part of that. And lots of the discussion was around the complexity in qualification and testing as you build. With monolithic, you have a single piece of silicon to test, but now you're building out in 2D and 3D. Could you just quickly, I know this is really high level, this is real nerdy stuff, but talk about some of the additional complexity in bringing a product like this to market when you have to worry about all of the, different processes building out in multiple directions, how that complicates the process of bringing something like Meteor Lake to market?
Yeah,
Go ahead,
sure.
Dan.
Like it certainly, like there are trade-offs, Marco, right? Which I think is what you're alluding to. So, in some respects, like it's kind of awesome for architecture, right? Like they get suddenly these huge degrees of freedom, and a great technology platform like Foveros, right? Suddenly there's a lot of different things we could do that we previously couldn't do within the monolithic or kind of the traditional Intel like 2-chip MCP approach. So from the architecture side of it, like suddenly there's this degree of freedom. Yeah, hey, in the back end of the execution, like in assembly, test, validation, certainly like there's more things to evaluate. But I think one of the things that I would just highlight here, and I think you guys heard some of this from Bill and the team, either at Malaysia or recently at Innovation, is there's a lot of yield benefits to this approach as well, right? And that's not necessarily like a product concept, but we are excited about what this has been able to help us do in terms of process development. So this is our first Intel 4 product here at Intel with Meteor Lake on the compute side. So we can have a really like fairly high yielding chiplet on that new process technology and really focus the development on those IPs. So this is in a way like helping the broader corporate strategy to sort of accelerate the pace of process development. Foveros is also a tool that allows us to execute that plan in addition to what we're trying to do in the PC.
Right. And those tiles, you guys are testing them as they're singulated before you even stack them together too, to make sure that they're good at that point before you put it together and find out, oh, this tile wasn't working. Now we've scrapped 3 other tiles. That's
right. Or alternatively, oh, this part of the monolithic die doesn't work, and now the whole thing is scrapped. Like it avoids that altogether. That's the yield issue that Dan was touching on. That's a major reason why you would even want to do this in the first place. Having a defective component doesn't deep six the entire part now.
Yeah, that is a great feature of chiplet in general. And I mean, is it safe to say that chiplet is the way of the future, moving forward for Intel processors? It certainly seems like it is for many different types of processor architectures.
Yeah, it's foundational, and it's part of how we're going to handle the architecture, the manufacturing execution, and also really like drive our strategy, right, to move the process nodes to forward in really rapid pace.
Gotcha.
Yeah. And I would add one follow-up. Yeah, just add one follow-up. Another key benefit that I think users will appreciate is, process technology is often one of lowest common denominator. And we know that IO stuff doesn't shrink well. In my time at AMD, I talked about that. That's a recurring theme in the industry. So being able to pick a process node that makes sense for what you're trying to implement is like this massive freedom in the design phase.
Is that because you say IO stuff doesn't shrink well? Is that because of the mixed signal nature of it, where you're dealing with interfaces, different types of interfaces? Why is that, Robert?
Yeah, it's no, that's a good question. It's just the nature of those external interfaces signaling to external devices. There's only so far you can shrink them. you stop getting power benefits out of it, or physically the geometry can't go that small.
Gotcha.
And Dave, one point that I think is like kind of really important for the audience, right? Kind of how to think about this new Foveros chiplet-based architecture from Intel. In every generation, like I mentioned, that architects have a lot of freedom now. So in every generation, because Foveros can allow a monolithic-like architecture, it actually gives a lot of freedom of how to draw those cut lines that you see on the diagram. So you shouldn't expect that we're locked into kind of like a rigid, like, hey, I kind of know how Intel does a desktop and a PCH, or in mobile, we had, a big compute die and then an integrated PCH. like every generation will actually reconsider where we draw those lines, right? Based on the process technologies that we have, the IPs that we have, the product portfolio that we're targeting, and the segments that we're targeting. So every generation, we can kind of draw it up a little bit differently and cut it differently and have a different family or library of tiles in a sense. So this is really like a pretty major shift, right? Because now like every gen, like as we look forward, and you saw a little bit of a preview of that on one of Robert's slides here at Innovation, like you can see the chip's going to look a little different each time on Foveros, but that's kind of the whole theory of Foveros, right? We can draw it up however we like each generation.
Right. And you're using two fabrics here. You've got the North network on chip fabric. That's your high performance. And then your IO fabric for the South side. That's, more energy efficient. Is that pretty well optimized for the kinds of devices you're seeing? Or is there room for maybe a third fabric in there that kind of hits a mid-tier kind of thing?
I don't actually know the answer to that question. I'll have to talk to the architects.
Thanks,
That's a
Chris.
good question. Yeah. All right. I'll just go away now.
Going back to my previous question, what asking about complexity with multiple dies. Intel built Ponte Vecchio with 47 functional tiles, so I'm sure there's no issues with Meteor Lake. I just wanted some color there, so I didn't want you to take that the wrong way. We have a couple of questions in the chat that I doubt you can answer, but I'm going to pop them up and just see if you can give any color. So I'm sure you guys are both familiar with with Kevin Crewell. He's got two questions. He's asking, will the CPU tile change for different SKUs?
Thinking. Dan, do you know?
Yeah, we'll have, without being too specific, Marco, as like we got just a couple of months here still, but we will have different configurations, both physically and logically.
I guess that's a good point, right? Like core counts do change up and down the stack. That's true of every CPU company. It's no different just because you're on Meteor Lake.
Got it. And he had a similar question for the GPU tile, so I'm assuming it's a similar answer. And then another question from KW on YouTube asking why the GPU tile lacks the XMX units of discrete ARC GPUs.
I know Tom answered that.
Yeah. My understanding, and again, I've only been here a few weeks, is that the ARC discrete, like you see on most integration efforts, is a gen ahead. And then, the N-1 architecture, N-0.5 or whatever IP node you're on, that's what gets integrated into the SoC type product. But that's true of Intel, that's true of AMD, and that's why the newer ARC discrete has them XMX arrays, whereas the Meteor Lake uses DP4A type arrays.
Got it.
Very cool. And actually, we have a question that relates to something we haven't talked about yet, AI, but want to come back to ARC as well, because there's a pretty interesting story there in terms of what ARC on the SoC can do. Jerry Elkins asks, as AI continues to become more and more ubiquitous and moves to the client, how does HotHardware anticipate benchmarking AI on your test benches? That is a great question, Jerry.
I have thoughts if you want me to turbo through that.
Yeah, I'll offer 2 cents, and then you can chime in, and then we should hear from the guys at Intel, because they have, I'm sure, an opinion on this too. But basically what we want to do is mimic real world use cases of an AI engine, and then measure the performance and battery life and all that good stuff that comes with it, thermals, what have you, the same way we do of any compute resource on chip, with real world application measurement. That's the hope. There will likely be, and there already are, some synthetic tests out there, but our objective always is to not only blend in some synthetics, because those paint a picture for you as well in some way, but also as many real world application use cases as we can provide. What I will say also as well is that I went out to Innovation this week with Intel with one big question in mind: what does the NPU on Meteor Lake actually bring the end user? And by that I mean, we all know the camera tricks, background blur, eye tracking, all that good stuff. which is almost like table stakes now, right? Everybody's doing it pretty much. But what else can you do with AI on a laptop chip with the NPU that's in Meteor Lake? And I was pleasantly surprised that that's what Intel did the entire show, was show different use cases, some pretty cool ones like Rewind. We can talk about that, but also the software enablement side of it, and just really what it means to the end user. I was pleasantly surprised and impressed that Intel had really thought that through and already is in motion with it. Marco, did you want to chime in on that? Go ahead, bud.
No, that was a perfect answer on how we test it. Just like my philosophy over the years has always been, use some sort of industry standard benchmark that a reader can download so they can test their systems and compare to new hardware, and then also use real world applications and come up with some sort of metric we can use to measure. But Dave sort of encapsulated how we would test in the future pretty well. So I think I'm good.
Okay. Gents from Intel, any thoughts on that?
I think we're on the same page. Benchmarking an actual application that a user can use, be it time to run or whatever performance metric that it has, is the way to go. A lot of these synthetic benchmarks will actually be more of a test of the framework used to build the benchmark than it will be the performance of the silicon underneath. And that's not to say there won't be any synthetic benchmarks that are useful, but frameworks are really important. Software is the make or break thing with any accelerator, and the NPU or its equivalent from other vendors is no different. So it's important to understand what framework was used to build the code path for the vendor being tested. And that is useful information, interesting information, but not always comparative information on the synthetic benchmarks.
Got it. Agreed. Yeah. Interesting. Dan, anything with respect to AI? Let's dive into that aspect a little bit more. I saw some amazing demos, believe it or not, and it's, we tend to be in the tech analyst community a little bit jaded, and we see a lot of innovation and a lot of what I call party tricks over the years. But I was genuinely impressed and amazed at the Rewind application that I saw, where this AI on the laptop was basically listening and taking notes in a meeting for you, and then you can go back and query it and have it play back even pieces of audio and video, and even encapsulate what the intent of a speaker was when they said something, and really just impressed me. Talk a little bit about what you folks are working on in that space, and how some of that stuff comes to pass.
Yeah, Robert can help unpack that for us.
Yeah, sure. So Rewind is very interesting. Office assistance type apps is as close as you're going to get to a killer app in the AI space, because we're all here dealing with email and correspondence on a regular basis, and so is every other worker on planet Earth that works in an office. So having that contextual ability to recall where you met someone, schedule a meeting, transcribe meeting notes, which we all hate, summarizing meeting, which we all hate. That's really cool. And so that Rewind AI application has been on Mac for a long time. Recently got ported to Windows thanks to OpenVINO. So that's a demonstration of Intel tooling, making it easier for devs to bring their AI software to Windows. And interestingly enough, that runs on both the CPU and the GPU, right? So one of the things that you'll see going into this AI PC era, whatever you want to call it, is all three engines will be used for AI use cases. CPU is good for latency, GPU is great for sustained high throughput, and NPU is good for offloading of quick tasks that can sap battery if you wake the GPU island or you wake up a bunch of cores to do the work. NPU is also great for long running AI workloads. So in the case of Rewind, it's GPU plus CPU. And of course, there were NPU demos as well. It's a really, really cool piece of software.
Very cool. What sorts of other things? I mean, Stable Diffusion, obviously, we've seen generative AI. techniques on on machines. What sorts of other use cases for AI that you see on the I guess near term and maybe long term horizon?
I can go near term. Gesture recognition is a big one. Computer vision, we've been using that for a long time to do gesture recognition, but moving that to the NPU is much more performant and power efficient. Green screening, like object detection on a green screen to matte the scene and remove background objects, is a great case for AI models. It's way more sophisticated than algorithmic models. Relighting scene, refusion, that is creating songs from a text input, creating music from a text input, like anything that's kind of a signal processing use case, be it image, audio, video, kind of the conventional editing and production workflows are already rapidly moving towards AI-based algorithms because they're much faster and much better than the other ways of doing it.
Very cool. Very cool. And actually, Chris put up on the screen a few minutes ago an example of a video I shot when I was out at Innovation. Meteor Lake laptop, by the way, thin and light. I'm talking 13 or 14 inch, what looks like a 3-pound class machine, doing just that. That picture you see on the right corner there, as soon as Ajith comes off the screen, he's teeing it up. He's demoing this. So I'm forgetting the name of the application. Maybe one of you guys can help me with it, but there's background replacement. That person is actually against a plain brick wall.
That's right.
Go ahead.
Yeah, I believe it's an application called Wondershare. And it's doing AI-driven background replacement, object detection of the subject in the foreground. Is doing real-time, essentially rotoscoping, right, to do the effects on the moving object and make sure they integrate seamlessly and don't like interfere with subject boundaries or look goofy or anything like that. These are all special effects that show up in movies, show up in music videos, show up in home production now, but like it's laborious with conventional algorithms, whereas you could just tell AI to do it for you, or you don't even need to manually mask the scene anymore. And if you've ever done frame by frame manual masking, it's an absolute time-sucking nightmare. So like,
the meme
I'm really happy to
generation
have
throughput's going to go through the roof.
I know, like it's going to be killer for memes. So like we joke about that, but it's true. Video memes, picture memes, like it's going to be a lot faster.
There you go. Yeah, and actually interesting there. You're seeing it at rest. You see a base clock of sub 2 gigahertz. But one thing we did learn about this chip that was in this machine, this Core Ultra machine, we're calling it Meteor Lake, but branded Core Ultra. It is a 16-core machine, and 2 of those cores, I believe, are on the low power island. E-cores, I should say, on the low power island. 8 are the rest of the E-cores on chip. And do I have that right? And then another 6 performance cores, right? Yeah. So 22 threads, 16 cores in a 3-pound machine. Do I have that right, gentlemen?
Sounds right to me.
About right.
Yep. We have like a 6+8, Dave, like in the peak compute configuration as an Alder Raptor, and then as you mentioned, like the 2 additional E-cores. Same IP, but configured very differently. In the what we call the SoC low power islands, which so it's the same ISA. It's fully visible to the operating system, programmable, user transparent. So there's nothing weird going on there. But they're configured electrically to be very efficient. So they run at a much lower voltage and on a different process technology.
Yeah, so that's on TSMC 6, correct?
That's right.
Were there particular challenges in porting the Intel IP to TSMC's process? Anything?
Meteor Lake was, I would say, just generally, Meteor Lake is an absolutely marvel of design execution for the team. So often, what comes with architecture creativity is a lot of design intensity to make that happen. So it's it was a big lift for our team. In Oregon and around the world. It's a global operation here at Intel. So for sure, yeah, a lot of work went into that. But we're very committed to this direction, right? We believe this is the right way for us to execute going forward.
There you go. Absolutely. And we will say shout out to Ryan Trout, who's in the audience from the Intel graphics team. Good to see you, buddy. And Robert's waving, and Robin getting some accolades for talking tech again. It is good to have Robert back talking tech again. I thought we were going to lose you to your passion project there. Didn't you invent something for, was it electric bikes or bikes of some sort?
Cars, actually. Yeah. Cars are my hobby outside of, that's my night job, and my hobby job that I created for myself is a water-cooled intake manifold for the BMW B58 motor, along with my business partner and I.
That's what I saw. That's what I saw. Well, you are a gearhead, as they say, in every sense of the word.
Yeah, I try. But, it's good to be back. I took a 1-year sabbatical, and month 1, 2, 3, just woke up every morning in a panic thinking I was missing meetings. Month 3 through 9.
PTSD there.
Pretty good. Month 3 through 9, and then 9 through 12, I was really bored, and Dan called at the right time. So here I am. Very good.
Very good. Good to have you.
It's cool how a performance mindset, right? Like performance people, it can transcend industries, right? Like this is it's kind of a cool thing. Like I think the automotive example is apt, and it's what's fun about the PC, right? Is that it's the ultimate performance.
It's true. It's very analogous. It's all benchmarks and numbers on the automotive side too. So it's like, do what you know.
And I think another CEO level guy shares your passion. Good old Wallace Santos from Main Gear, big car guy. Even stylizes the production floor of their custom boutique systems, the production floor, and the folks wearing the uniforms like a car shop. I mean, it literally looks like a car shop. It's really cool to see.
It's very cool.
Shout out to Main Gear. Yeah. Marco, what else we got for questions? We got all kinds of questions.
I think we got to go back to nuts and bolts. Let's talk about the cores, right? I know there's not a huge architecture change between the P cores and E cores on Meteor Lake, but can you guys? There are some changes, and then obviously using the new Intel 4 process enables new things for you guys. Can you talk about how the P cores and E cores differ from previous gen architectures, sort of the benefits you get with Intel 4, and then just to add another layer, how the E cores on the CPU tile differ from the E cores on the low power E cores on the SoC tile?
That was my question too.
Yeah, Dan, go ahead, take that one.
Yeah, sure. So the P cores are, we have a nice, pretty rich description here, Marco, right, for the audience. So definitely check out the content and zoom in this for the full description, because we lay out really the whole architecture here. But just at a high level, the P cores really are largely a port from the older process to the new Intel 4 process technology. There are some smaller improvements, but the IPC expectations are roughly the same. So you can think of the P cores as being, kind of equivalent to where they were on Raptor by and large, but with some pretty significant improvements in efficiency and power.
There was an L2 cache bump, right?
L2 cache is also updated. And this is, there's kind of this looming question, hey, is what's going on with desktop, and is there a Meteor Lake desktop? And you can kind of see that clearly our focus of this product, if you step back and think about the P cores, the graphics, the AI, the low power engine, right? This is a product that's really squarely architected on efficiency first, right? Which is really different from where we were with Alder and Raptor, which were super performance first, right? That was absolutely our design intent. So that's for that reason, we're starting with mobile with Meteor Lake, right? So you can expect a fairly rich mobile lineup. And then this architecture will then scale forward into desktop and other segments as we expand from here. So I'll just hit that question head on before it's asked, because I know it's a really important one for the audience.
It was out there. We missed it. Good job.
There we go.
No problem. I can host Dave maybe next time too. But good job. I think so. Then on the E cores, there's actually some more significant improvements on the E cores, if you just want to scroll through. So here we do actually have some meaningful IPC improvements as well. Again, efficiency focus, right? So E cores are upgraded, and of course on the new process technology. And then we're extending, right? So we have this sort of third tier of hybrid. And there's a pretty nice cartoon kind of illustration of this that Rashri, who's one of our senior software architects, this is perfect. This is a really nice like sort of visual to understand how the scheduling and how the different tiers of hybrid are working in Meteor Lake. And those E-cores that we have in the low power island or in the SoC tile are the same IP. So it's that same exact IP set. It's just on a different process technology with a different electrical infrastructure, lower voltage, and a faster path to memory as well. So they sort of sit with the media engine. So the idea being that, in these low power use cases like video playback, you can operate exclusively out of the SoC, shut down the compute tile, and enter lower power states for the SOC.
Yep.
That is slick. All right.
Very cool.
Good to know that. Yeah, I wondered, and you said lower latency to cache, or lower.
So the memory controller is right on the same tile, right on this major SoC tile. So you kind of have your memory there, you have your low power fabric, you have your low power E-cores, you have your media engine. So you sort of have all the assets you need right there to handle your video playback cases.
Got it. So
and this is another kind of note, is that like kind of the whole concept of our graphics IP is also like sort of wildly disaggregated. And, we have some visuals, and like Robert can elaborate on this too, but like it's kind of strewn across all the different tiles, right? And again, that's with a mind towards taking advantage of Foveros, taking advantage of this architecture, and also like driving greater efficiency overall for these key use cases.
Very cool. Should we talk graphics since Ryan's here? Arc. I did have some questions about Arc because there were some impressive performance claims made. Arc in this implementation, the Arc GPU reportedly 2x the performance of your current generation integrated solution. Maybe expand on that a little bit. And there was also a claim that if I'm not mistaken, that you guys are going to be some of the best, if not the best, most potent integrated graphics solution on the market when this thing hits in December. Is that a fair? Did I get that right, or was I dreaming?
I believe that to be true. Yes, based on the numbers that I'm seeing, which I know is a wild claim, but I'm pretty confident in it.
All right, so there you go, confirmed. So tell us a little bit about what makes Arc in this SoC special, and how you got to that performance level, because that is a bold claim. AMD, let's be honest, AMD has a very strong IGP, as you know, IGP track record as of late. And just some additional color around that would be great.
So all apologies to Mr. Shroud and the graphics team. I'm going to take up the graphics mantle for just a second here. Arc is so obviously incredibly good at performance per watt. It's been demonstrated time and time again, and where that really pays dividends is when you start integrating into an SoC. And as we know from, for example, the Vegas story on my previous employer's side, performance per watt is very instructive when you start going into the 15, 28, 35 watt power envelopes that typical notebook CPUs play. And so bringing a very modern Arc-based graphics core into the device simply allows us to scale frequencies higher, go wider on the device, get more out of every shader engine than previously, and net, you get this massive bump in delivered graphics performance. The disaggregation helps a bit too. Dan touched on this, like bringing the media engine out of the graphics tile into the SoC tile frees up kind of more area in the graphics specific components. And that's a source of power usage that is now divorced from the graphics engine. It sits somewhere else, has different voltage supply. So there's even minor stuff like that, like cutting the actual graphics core or graphics tile up into pieces and spreading it across the chip pays dividends as well in terms of performance per watt. So it's not just the architecture, it's also the construction that contributes as well.
So you disaggregated Ryan's chip too.
Yes, we did.
There's actually a
like that.
perfect time to answer a question that came in the chat. So KW is asking, is there a tiny Intel GPU in the SoC tile when the GPU is shut off? Now, I think the answer is no, because the display engine is in the SoC. The question that I sort of have is there a means where, let's say, the display is lit up, but the GPU is idle? Can the GPU shut off while you still have an image displayed on screen?
Yes, that is possible. It's a technology called panel self-refresh, or PSR. And in certain cases, yes, you can fully gate the graphics island and just run the panel by itself. And it usually involves a timing controller or Tcon in the display that has some amount of memory of its own to hold and self-refresh the image. But certainly that's a really key way that modern innovative power management schemes are showing up in laptops, but may not always be obvious to the user.
Got it. Very cool.
And you guys have gone a step beyond that too, with the kind of burst decode thing here, where when you have video playback, I think Tom said you're decoding 16 frames at a time all up front and then pacing those out to display as they need to show up. So while it's going through that cycle of just doling out those frames, you have way less power usage in general with that as well.
That's right. Well, is it any surprise that Tom's talking about frame pacing?
But
it's true. It's true. It's a great technology. There's all sorts of panel and video related stuff. There was a demo at Innovation where there was variable refresh rate with no OS involvement at all, or no driver involvement at all, which seems interesting, but is now possible with modern Tcons and the implementations we brought into Meteor Lake to talk to those kinds of displays.
Let's talk about that, because I actually have, and we have to post a video demo of that I shot. And I believe it was demoed on a Sharp laptop display. Mike Bartz was there, by the way. It was good to see Mike again. And he was running that booth. And so, yeah, there were two technologies involved, both of which, maybe three actually, that impact or help significantly with battery life. There was what you just spoke of, and I'm forgetting the acronym for that again. And then there was another technology that was similar to the way an OLED display shuts off pixels in completely black regions of an image for contrast. But in this case, you were powering down pixels, or using the Tcon to power down pixels. Again, this was separate of the OS in regions for power savings. And then I also saw another. It wasn't panel self refresh. It was limiting maybe it's the same technology and I'm just conflating it. It was limiting the frame rate when not necessary. So let's say you had a 120 hertz panel when you're watching streaming Netflix, and you're looking at probably 30p or 60p at most, and there's no cursor movement. It limits the refresh rate down to that speed, automatically saving you power as well. That's how I kind of remember it, but maybe talk a little bit about that, because I thought in conjunction with Meteor Lake technology, that's going to make for a very power efficient laptop.
Yeah, you kind of nailed it. You got the summary of those technologies perfectly. Essentially, what it allows the device to do is get the panel to one-ish watts of power consumption, sometimes less. And the panel is such a massive contributor to overall battery life, or reduced battery life, depending on what technology it uses and who builds it. And so aggressively managing the power of the panel and building in display engine capabilities to talk to those new technologies is such a fundamental part of platform power management, not necessarily core power management. And platform is actually the biggest contributor these days to the overall battery life. And so it's not enough anymore to just have an efficient core or an efficient GPU or whatever. You need really strong media engines, display output capabilities to manage and interface with these very active components outside of your own CPU. It's like there are no dumb panels anymore, right? You're managing backlight brightness by region. You're managing refresh rate by content type on the screen. You can let the screen go to sleep without putting the computer to sleep, like a smartphone can. And actually, the smartphone is a good example, right? I'm actually on a Pixel 6 Pro right now, and it has adaptive refresh rate, depending on whether or not I'm touching the screen. And it's the same model for interactivity or content-based instead on a laptop.
Impressive, actually. Your video and audio is pretty darn good, Robert, for phone.
Yeah, I'm happy with it. Like, it's a great device.
Very cool. What were the acronyms again that I was missing there?
Oh gosh, I can't remember. Dan, do you remember?
Yeah, I don't remember. I would just maybe make like kind of a higher point, and I think like certainly Ryan and Tom on the team, right? They can do a real nice job like unpacking the full richness of the feature set. But like you heard like we're kind of excited about the perf per watt improvements of the IP in the process and how that will ultimately deliver performance. So like that will be the headline likely. But the feature set's also great, right? It's a really modern, complete graphics feature set, both 3D and 2D. And we can, we have all those details. We'd be happy to share more on that too. But you're getting, even like you get XCSS, you get even like ray tracing, like you get the full ARC feature set now in this integrated form factor. So like the features are probably as notable, if not more, even than of course like the big improvement in performance.
Yeah. Yeah. And actually we should, and we're getting close to wrapping up here, but we could talk forever, by the way. This is quite enjoyable.
Yeah.
Let's talk about ARC performance in this, one more time. Are we talking about, sort of put it, if we can, without disclosing too much or putting you guys on the hot seat. Can we talk about like what sort of gaming experience we can expect on a machine with integrated ARC graphics? Obviously, integrated graphics in years gone by have not been really able to deliver, a high-end gaming. Well, they certainly high-end gaming experience, but we always wanted more, right? You always seem to want more from the integrated graphics in terms of gaming. Where are we at now? Is it 1080p medium image quality, or can you kind of put a dot at it or a dart on it somehow?
Dave, I think you're in the ballpark. It's going to be comparable to entry-level gaming Discrete, which, as we know, a lot of people rely on and works really well for damn near everything.
Okay.
And I'm not going to go say like it's a gaming notebook. It's not, right? I want to be clear about that. But people want to be able to play a game on the SoC and not suffer crappy frame rates or missing feature sets and stuff. And ARC absolutely delivers. It's really, really solid.
Very cool.
So am I going to regret my purchase of a XPS 15 with the ARC A370M graphics in it? Am I going to feel like I'm really missing out?
No, I don't think so. But I think you'll be surprised at how comparable it is.
Okay, yeah, and that's good to know. Good insight there. Thank you. Let's finish up on the NPU real quick. Tell us a little bit about more of that, because that's new IP. How I guess, I don't know if maybe we could just delve a little bit into what makes it special, what's different versus perhaps putting something on a load on the GPU. Walk us through that just a little bit, and then we'll wrap up and let you guys actually get back to getting some work done.
Well, I think it starts actually with the GPU. That's the common understanding we all have, which is in and of itself great at AI throughput because it's a large vector engine or matrix engine, and so is AI workloads, like a lot of matrix math, tensor math. And the problem with the GPU, though, is it's relatively high power compared to what an NPU can do. So you can think of the NPU as GPU-like in its duplication of common execution engines, right? GPU uses the same type of core over and over, and so does an NPU, but it's a lot more efficient in terms of power compared to the GPU. So as we look at these workloads coming online that are AI driven, adding an NPU in the processor makes a lot of sense because it allows us to offload from the graphics core when necessary to improve both performance and battery life. And I think in 2 years' time, 3 years' time, every CPU is going to have an NPU. This is a new third column of workloads of execution type that's just going to become commonplace. And it's incumbent upon us at Intel and at other vendors to make this transition seamless and happy for users. And we're well down that path. Intel's been doing this for a long time, and it's one of the reasons why I joined.
There you go. Good stuff. And I think that probably brings us to the wrap, but we'll throw one more in here. Can you talk about DGPU attach with respect to, I guess, Meteor Lake and or future? That's obviously still part of the plan of record, or can you just talk a little bit about that without getting too far into, getting you in trouble?
Talking about attach alongside Meteor Lake, or?
Yeah, just in general.
Dan, I think you have some better knowledge of the design win assortment than I do. Why don't you take that one?
Yeah, perfectly possible, and we certainly expect to see Meteor Lake with discrete graphics and mobile. Absolutely. It's you guys know kind of our alphabet of mobile product lines, right? So we will have our H series type of a product that pairs with discrete graphics. Absolutely, right? Which is key for sort of like real mobile oriented kind of like gaming systems, like super thin systems, or real mobile oriented, or of course creator systems. And one of the nice things too is like it gives our OEMs the flexibility to offer a discrete configuration and an integrated configuration, and you get that kind of mixing and matching within a chassis too as another option. Now that the graphics internally has been so nicely upgraded with ARC.
Very cool, very cool. And Marco, you look like you're about to say something there.
Well, can you guys have just 2 minutes, or we got to cut, or are we good
can
to
do
go
2
for
minutes.
one more?
Yeah,
So just quickly, like anytime there's a big show and like innovation, the info it's coming fast and furious, and it's impossible to cover everything. And I'm just wondering, from your guys' perspective, was there any disclosure or any nuance about Meteor Lake that came out of innovation that didn't get the fanfare it deserved? Is there anything you want to make sure the audience knows about Meteor Lake that sort of didn't have the coverage that you wanted?
I have a question for Robert. Can I ask that one?
Okay. All right. Go ahead.
And it's not, hey, how does the blue feel? Not that question, but he's gotten that one enough. I think we spent a lot of time talking about hardware, right? Which is kind of and also the construction. But I think a really important part of the strategy, Marco, is actually the software. And kind of to your point, right, gets a little overlooked, right? It's Intel, we're talking hardware. That's always what we like to do. But I think it'd be good for Robert to share a little bit too about the work he's been doing on the software side, because that's like really important to what we're seeking to achieve with this product as well.
Okay. Yeah, that's a good point. So we think about the 3D accelerator, which has been around since 1996-ish, go Voodoo. And we think about the CPU, which has been around, 50, 60 years at this point. What's true of both of those accelerators is that we have, all of us watching here on this call, an implicit trust that if you download the piece of software, you can just run it and it will work. It's frictionless, right? That's because we've had decades of time to develop APIs, frameworks, compatibility models, right? That takes hard-nosed software engineering effort to be as transparent as it is now. Intel had started that work on AI software, like to the public exposure, 2016, with the addition of bfloat 16 and VNNI type instructions in a CPU. And the real work of getting to that point that the public sees starts, 4 to 5 years before that. So now we're all the way backed up to 2011, 2010 timeframe. So here we are, 13 years later, almost 14 years later, with an integrated AI accelerator, and Intel has by far the most sophisticated tool chain and development environments for developers looking to get into AI development. That's the OpenVINO tool. We were also the first to support DirectML, Windows ML, which is cross-vendor AI acceleration framework. We support Onyx, which is also cross-vendor. We have our fingers in a ton of cross-vendor, open source, multi-party consortium pies to make sure that this AI thing is seamless. And the one thing that I'd want to leave you with is the public record of AI delivered software. By Q1 of 2024, Intel's going to have 13, 14 shipping pieces of software, each with 3 to 5 AI accelerated features. We understand there's competitive choices in the market, but they've delivered 1 to 2 shipping user-facing pieces of software, and they had a year's head start or more on Intel with a shipping device. Right, so I think that reflects just the scale of what Intel can do, manpower-wise, investment-wise, partnership-wise. Scale really, really matters when software is the deciding factor. And already the scale of what Intel is delivering is 5 to 10 times larger, and you can't even buy our NPU yet, right? And I think that's really reflective.
Very cool. Yeah, no, that's a very good point. Thank you, Dan, for teeing that up for us again. Once again, co-hosting here. Appreciate that.
Well, we had Chris doing some pretty good answers too, so it's reciprocal here.
Yeah.
But it's obvious. Yeah, software was a huge component of the discussion at Intel Innovation 2023 out in San Jose this week. So that makes perfect sense. And one last question before we wrap up. OpenVINO, the way I understood the way you're looking at it now strategically as a company, in addition to it being open source, it's essentially a lightweight wrapper to bring in these different frameworks and optimize for your hardware. Is that fair?
That's right.
Okay.
That's fair. Developers writing AI code have lots of different frameworks to choose from, and the different frameworks depend on either your personal preference or what kind of AI software you want to run. And OpenVINO allows you to just pick your chosen framework. We support the most frameworks of any of the CPU vendors. And then through OpenVINO, you can target pretty much any hardware device. You can target CPU, integrated graphics, discrete. You can target NPU. You can target server processor, embedded, just pick, right? And that's the magic of OpenVINO. Choose anything to anything. And that's extremely powerful. But again, we recognize that Intel to Intel is only one way that people will access this hardware. And that's why we also support multi-party options like DirectML and Windows ML.
Yep. Yeah, thanks for giving us the opportunity to talk a bit about it, because as I mentioned, obviously we always are excited to talk hardware at Intel, but I think one thing that the audience and the team will you'll see more from us right over the next couple of months as we get closer to launch. This is probably the most software first launch and go to market approach that we've had at Intel, at least since I've been in this client game the last several years. So that's going to be really different. And it's what may distinguish actually Meteor Lake the most in the market, and for actually the experience that people get ultimately when they get to enjoy the device. Very cool.
Good stuff, gentlemen. That sounds like a good plan to me. And we thank you very much for your extended time here today. It's always good catching up with you, but giving us such a big chunk of your time, the both of you.
Hell
Yeah,
yeah,
you'll have
guys.
to get
Like,
our ARC friends on here soon, Dave.
Yeah.
We'll get Tom and Ryan on. We'll do some more on ARC.
Yeah, that'd be great. That'd be great. Absolutely. Always good to talk to Ryan and Tap. Absolutely. Well, gentlemen, with that, I think we should probably let you off the hook and say goodbye for now. And yeah, I mean, Dan, I think thanks for not taking my job moving forward. I think you have a pretty good job
Not yet.
Intel, so don't take mine. But it was a pleasure chatting with you guys as always. Folks, stop by HotHardware.com where you can find all of these articles on the web that I linked in the chat. We are live 1 p.m. on Fridays now, and you should find us here. And we'll hopefully have the ARC team on, the Intel ARC team on in future episodes. But find us around the web at HotHardware.com, Twitter.com/HotHardware, YouTube.com/HotHardware. We're everywhere. Hit thumbs up and subscribe, would you please? So you get notified when we go live, and you get to get some time with some exciting folks like these guys from Intel. Robert, Hallock, Daniel Rogers, thanks for joining us.
Thanks, guys. Thanks for having us.